Picture this. It's 1968, and a 16-year-old kid walks into a Virginia junkyard with $30 in his pocket. He pulls an engine that Chrysler engineers had literally thrown away, declared obsolete, abandoned for newer technology. 6 weeks later, that same kid is watching $8,000 muscle cars disappear in his rearview mirror. This is the story of how Richard Petty Jr., a teenage mechanic from Richmond, Virginia, built a $55 engine that embarrassed Chrysler's entire engineering department and rewrote what everyone thought they knew about Mopar performance. The kid had no relation to the famous Petty racing family, just shared the name and apparently the talent for making Chrysler engines do impossible things. What he did with a discarded Poly 318 in his parents' garage would become legend among Mopar enthusiasts. But more than that, it proved a fundamental truth about engineering that Detroit had forgotten. Sometimes the newest technology isn't the best technology. Sometimes what you need isn't innovation, it's understanding. To grasp the magnitude of what this teenager accomplished, we need to understand what Chrysler had just thrown away. The polyspherical combustion chamber design, or poly as gearheads called it, represented one of the most sophisticated approaches to combustion efficiency ever attempted in a production V8. Introduced in the mid-1950s, the poly head featured a unique semi-hemispherical combustion chamber that wasn't quite a full Hemi, but wasn't a conventional wedge either. The valves were canted at opposing angles, creating a polyspherical shape that promoted excellent flame propagation and breathing characteristics. Think of it this way. In a conventional wedge head, the combustion chamber is essentially a flat surface with a slight angle, like a doorstop. The poly chamber was more like the inside of a dome that had been slightly squashed. This shape allowed for larger valves, better mixture motion, and more efficient combustion. The intake valve measured 1.78 inches, the exhaust 1.50 inches. Those might not sound impressive today, but in a 318 cubic inch engine, those were substantial. The valve angles were set at 18 degrees for the intake, 15 degrees for the exhaust, creating what engineers called a cross-flow effect, even though it was still a conventional single-cam design. Chrysler had spent millions developing this technology through the late 1950s and early 1960s. The Poly 318 that ended up in junkyards across America featured a bore of 3.91 inches and a stroke of 3.31 inches, giving it 318.5 cubic inches of displacement. Stock compression ratio was 9.0.1, factory rated at 230 horsepower and 340 lb-ft of torque with a 2-barrel carburetor, or 260 horsepower with the 4-barrel option. These weren't spectacular numbers, but they were respectable for a small block engine of the era. But here's where the story gets interesting. In 1967, Chrysler made a decision that would haunt them. The accounting department had been pressuring engineering to reduce manufacturing costs. The polyheads, with their complex combustion chambers and angled valves, cost significantly more to machine than simple wedge heads. The bean counters calculated that switching to wedge heads across the entire LA engine family would save $4.50 per engine. Multiply that by hundreds of thousands of engines per year, and you're talking serious money, the engineers protested. The poly design had untapped potential, they argued. With proper development, it could match or exceed the wedge head's performance while maintaining better fuel economy and smoother operation. But the decision had already been made. In late 1966, the last Poly 318 rolled off the assembly line. By 1967, every Chrysler small block featured the cheaper wedge-style heads. The LA 318 that replaced the Poly made the same 230 horsepower but cost less to build. Progress, Chrysler called it. Within months, thousands of Poly engines began appearing in junkyards. Cars were wrecked, engines were swapped, and since the Poly was now obsolete, nobody wanted them for rebuilds. You could buy a complete Poly 318 for the price of scrap metal, usually $20 to $40. Most ended up in the crusher. The hot rodders chasing quarter-mile times wanted the new 340s and 383s. The Poly was yesterday's news. Enter Richard Petty Jr., a high school junior who worked part-time at a Richmond machine shop. Petty had been racing a tired 273 Dart at the local strips, consistently getting his doors blown off by big block cars. He didn't have money for a 383 or 440. Hell, he barely had money for gas. But he had something more valuable, access to machine tools and an understanding of fluid dynamics that would make college professors jealous. Petty had been studying the Poly design in shop manuals, running calculations on a slide rule late into the night. The polyspherical chamber, he realized, had been handicapped from the factory by conservative cam timing and restrictive ports. The combustion chamber shape was actually superior to the wedge for maintaining mixture velocity at low lift. The problem wasn't the design, it was the execution. In April 1968, Petty found his donor engine. A 1964 Dodge pickup had been rear-ended and totaled. The Poly 318 had 90,000 miles but still had good compression. The junkyard wanted $30. Petty negotiated it down to $25, then spent another $5 on a timing chain and gaskets. That was his entire budget gone. Everything else would have to come from skill and borrowed machine time. What Petty did next was a masterclass in understanding airflow. Using nothing but a die grinder and carbide burrs borrowed from the shop, he spent 3 weeks porting the heads. But this wasn't random grinding. Petty had studied the work of Smokey Yunick and other engine masters. He understood that airflow wasn't just about making ports bigger. It was about velocity, direction, and maintaining the proper cross-sectional area throughout the entire port. The Poly's intake ports measured 1.65 inches by 1.15 inches at the gasket surface. Petty enlarged them to 1.74 by 1.20 inches, but more importantly, he reshaped the short side radius where the port turns down toward the valve. This is the critical area where most airflow is lost. He spent 6 hours on each port, carefully maintaining the proper taper and avoiding the common mistake of hogging out the port bowl. The exhaust ports received similar attention. Petty focused on the area just past the valve guide, where the factory casting left a significant restriction. He blended the guide boss into the port wall, creating a smooth transition that improved flow by an estimated 15%. Remember, he's doing this by hand, by feel, without a flow bench to verify his work. The combustion chambers were next. The factory Poly chambers measured 62 sus. Through careful blending and polishing, Petty smoothed the transitions around the valves without significantly increasing the volume. He maintained a 61 cc chamber volume, critical for his compression calculations. Every edge was radiused, every surface polished to a mirror finish using progressively finer sandpaper until he reached 600 grit. Now came the really clever part. Petty had calculated that the Poly's valve angles and chamber shape would tolerate significantly more compression than a wedge head without detonation. The polyspherical shape promoted faster, more complete combustion, reducing the tendency toward knock. While everyone was running 9.1 or 9.5.1 compression on pump gas, Petty aimed for 10.1. He achieved this through a combination of milling and piston selection. The block deck was milled 0.020 inches. The heads were milled 0.015 inches. But the real trick was finding pistons. Petty discovered that 1962 Dodge Truck 318 Polys came with higher compression pistons from the factory, designed for better torque at low RPM. He found a set in a wrecked stake body truck, pistons that would have cost $120 new for the princely sum of $0. The junkyard owner let him have them in exchange for helping pull an engine the next Saturday. The pistons were cleaned, the rings replaced with file-fit chrome moly rings that Petty got from a shop customer who'd ordered the wrong size. The ring gaps were set at 0.08 inches for the top ring, 0.016 for the second. tighter than factory spec, but Petty had calculated the thermal expansion precisely. The bearings were standard size, another stroke of luck, as the crankshaft journals were still within specification despite the mileage. The camshaft selection showed Petty's deep understanding of the Poly's characteristics. Everyone was running huge duration cams, chasing that lopey idle that sounded fast. Petty went the opposite direction. He found a used Isky 505T camshaft with 268 degrees of advertised duration and 0.465 inches of lift. Relatively mild by 1968 standards, but perfect for the Poly's port velocity characteristics. The cam was degreed in at 106 degrees intake centerline, 2 degrees advanced from the standard 108-degree setting. This improved low-end torque while maintaining top-end power. The valve train was equally thoughtful. Petty shimmed the hydraulic lifters to reduce preload to 0.020 inches, effectively turning them into solid lifters without the maintenance hassles. The rocker arms were stock, but he corrected their geometry with longer push rods made from 3 8-inch seamless tubing. The valve springs were beehive units from a 273 4-barrel engine, stiffer than stock Poly springs, but not so stiff as to cause excessive wear. The induction system was where Petty really showed his genius. Everyone assumed bigger was better. 4-barrel carburetors were the hot ticket. But Petty understood that velocity was king, especially with the Poly's excellent chamber design. He used a factory 1966 Plymouth 4-barrel intake manifold, but topped it with a relatively small 600 CFM vacuum secondary Holly that he borrowed from a friend's broken 340 car. The primaries were rejetted down 2 sizes to 64s. The secondaries remained at stock 72s. The accelerator pump cam was changed to the pink profile for quicker fuel delivery. The ignition system received equal attention. Petty recurved the distributor using lighter springs from a slant 6 distributor. This brought total advance in by 2,800 RPM instead of the factory 4,000 RPM setting. Total advance was limited to 34 degrees. The initial timing was set at 14 degrees, aggressive for the era, but perfect for the Poly's fast burn chambers. He gapped the plugs at 0.035 inches, running Champions rated 1 heat range colder than stock. The exhaust system was perhaps the most unconventional choice. While everyone was running massive headers, Petty used stock 340 high-performance manifolds that he found at a swap meet for $10. These manifolds, designed for the wedge heads, required minor grinding to fit the Poly's different port locations, but their 2.25-inch outlets were perfectly sized for the engine's actual airflow requirements. He paired them with a dual 2.25-inch exhaust system scavenged from a wrecked Roadrunner. Here's the thing about engine building that most people don't understand. It's not about peak numbers. It's about the area under the curve. An engine that makes 300 horsepower from 3,000 to 6,000 RPM is far more useful than one that makes 350 horsepower only at 6,500 RPM. Petty understood this intuitively. Every modification was chosen to work together to complement the Poly's inherent characteristics rather than fight them. The finished engine was installed in Petty's 1965 Dart, replacing the tired 273. The car was nothing special to look at. Faded blue paint, some primer spots, steel wheels with dog dish hubcaps. The interior was stripped except for the driver's seat and a Stewart Warner tachometer bolted to the steering column. The transmission was a worked 727 torque flight with a stock converter that stalled at 2,200 RPM. The rear axle was an 8.75-inch with 3.91 gears, considered too tall by most racers who preferred 4.10s or 4.566. On May 18, 1968, Petty fired the engine for the first time. The Poly burst to life immediately, settling into a smooth idle at 850 RPM. No lopey cam, no rough idle that everyone associated with performance. It sounded almost stock, just with a deeper exhaust note. Petty spent 2 weeks tuning, adjusting the carburetor mixture screws by reading the spark plugs, advancing and retarding the timing by single degrees to find the sweet spot. The first trip to Suffolk drag strip was meant to be a shakedown run. Petty expected maybe low 14s, respectable for a 318. His first pass was a 1342 at 102 mph. The time slip didn't make sense. He thought the timing system had malfunctioned. The second pass was a 1338 at 103 mph. By the third pass, word had spread through the pits. The kid with the primer-spotted dart was running deep 13s with a 318. But the real shock came the next weekend at Virginia Motorsports Park. Petty had spent the week fine-tuning, adjusting the shift points, optimizing the launch RPM. His opponent in the first round of eliminations was a 1968 Roadrunner with a 383 four-barrel, factory rated at 335 horsepower. The owner had added headers and slicks, confident his big block would destroy the small block dart. The tree dropped. Petty left at 2400 RPM, the poly pulling hard from the hit. The torque flight shifted at 5800 RPM, well below what most considered optimal, but perfect for the poly's torque curve. The Roadrunner got the jump, pulling half a car length by the 60-foot mark, but as they passed the 8th mile, the dart was gaining. By the 1,000-foot mark, they were dead even. At the stripe, Petty was ahead by a fender. The time slips told the story. Petty ran a 12.64 at 107 mph. The Roadrunner managed a 12.71 at 106 mph. A 318 had just outrun a 383, giving up 65 cubic inches and supposedly 105 horsepower. The Roadrunner owner demanded to see under the hood, convinced Petty was hiding a 440, or at least a 340. When he saw the obviously stock polyvalve covers, he walked away shaking his head. Word spread through Virginia's drag racing community like wildfire. The following weekend, Petty faced a gauntlet of challengers, a 383 Super Bee, a 340 Duster, even a 440 GTX showed up specifically to put the upstart 318 in its place. Petty won more than he lost, consistently running 1260s to 1270s. The poly never missed a beat, never overheated, never broke. But the real validation came from an unexpected source. A Chrysler engineer named Tom Hoover, one of the fathers of the 426 Hemi, heard about Petty's poly through the grapevine. Hoover had always believed the poly design had been abandoned prematurely. He drove down from Detroit to see the engine for himself. What Hoover found confirmed his suspicions. On his flow bench back in Detroit, using heads Petty had prepared, the poly 318 heads flowed 195 CFM at 0.500-inch lift on the intake side, 155 CFM on the exhaust. These numbers matched or exceeded the contemporary 340 wedge heads. The combustion efficiency was even more impressive. The poly's fast burn characteristics meant it needed less total timing, reducing negative work on the compression stroke. It could run higher compression on lower octane fuel. The polyspherical chamber promoted better mixture motion, more complete combustion, lower emissions. Hoover estimated Petty's engine was making 380 horsepower at 5,600 RPM and 405 lb-ft of torque at 3,800 RPM. These weren't just impressive numbers for a 318, they were impressive numbers, period. The 383 Roadrunner engine with 65 more cubic inches was only rated at 335 horsepower. The 340, Chrysler's pride and joy small block, made 275 horsepower from the factory. Petty had built something that split the difference while using yesterday's technology. The implications were staggering. Chrysler had spent millions developing the new LA Series wedge heads, abandoning the poly to save $4.50 per engine. Yet here was proof that with proper development, the poly could have been their performance leader. The polyspherical design offered advantages that wouldn't be fully appreciated until decades later when pent roof and four-valve designs became common. The poly was essentially a two-valve version of what would become modern combustion chamber technology. Petty's success sparked a cult following among Mopar enthusiasts. Suddenly, those unwanted poly engines in junkyards became hot commodities. Racers who had overlooked them began applying Petty's techniques. The recipe spread through bench racing sessions and tech articles in Hot Rod magazine. Port here, mill there, cam selection is critical, compression is your friend. Within a year, poly-powered cars were showing up at drag strips across the country, shocking the establishment with their unlikely performance. The techniques Petty pioneered went beyond just the poly engine. He had demonstrated fundamental principles that applied to any engine building. First, understanding the design philosophy of your engine was more important than following conventional wisdom. Second, velocity trumped volume in port design. Third, the combustion chamber shape determined how much compression you could safely run. Fourth, camshaft selection should match the port velocity characteristics, not chase arbitrary duration numbers. But perhaps the most important lesson was about innovation itself. Petty had taken what everyone considered obsolete technology and made it competitive with the latest designs. He proved that newer doesn't automatically mean better. Sometimes the abandoned technology was abandoned for the wrong reasons, usually financial rather than technical. The poly wasn't killed because it was inferior. It was killed because it was expensive to manufacture. This story resonated beyond just the Mopar community. It was a David versus Goliath tale that spoke to every underdog who'd been told their ideas were outdated. It validated the hot rodders who believed in building what they had rather than buying what was popular. It showed that knowledge and skill could overcome cubic inches and corporate engineering. The financial aspect made it even more remarkable. Petty had spent exactly $55 cash, plus some borrowed machine time and salvaged parts. A new 383 crate engine cost $200 in 1968. A built 340 was at least $800. Professional porting and machine work would run $400 minimum. Petty had achieved more with $55 and teenage determination than others achieved with thousands. His story also highlighted a critical transition period in American automotive history. The muscle car era was at its peak in 1968. Compression ratios were climbing, horsepower numbers were escalating, and the only question seemed to be how big an engine you could stuff under the hood. But the insurance companies were already sharpening their knives. Emissions regulations were on the horizon. Within 3 years, compression ratios would plummet, horsepower would crater, and the party would be over. Petty's poly represented a road not taken. Its efficient combustion and lower emissions could have better weathered the coming storm. The polyspherical chamber's characteristics would have adapted better to unleaded fuel and catalytic converters. Instead, Chrysler stuck with the wedge design, suffering through the malaise era of the 1970s with smogged, low-compression, wheezing engines that made less power than Petty's $55 poly. The Poly 318 story became legend, but Richard Petty Jr. himself remained largely unknown outside Virginia racing circles. He never sought fame, never tried to capitalize on his creation. He went on to become a mechanical engineer, working ironically enough for Ford Motor Company in their racing division. When asked years later about the poly, he said simply, "I just wanted to go fast and didn't have money. The poly was there, so I made it work." The engine itself survived until 1973, when Petty finally hurt it, attempting a 7-second eighth-mile pass. A connecting rod failed at 7,200 RPM, well beyond what any poly was designed to handle. By then, it had won countless races, reset expectations, and inspired a generation of engine builders. Petty kept the damaged block, eventually having it bronzed and mounted on his office wall, a $55 monument to ingenuity over income. Today, poly engines command premium prices when they surface. A good core sells for $500 to $800, 10 times what they cost in junkyards just 5 years after Petty's breakthrough. Builders following his blueprint regularly achieve 400-plus horsepower from 318 inches. The Poly has been vindicated by history, recognized as one of Chrysler's most underappreciated designs. Modern technology has proven what Petty understood intuitively. Computational fluid dynamics shows the polyspherical chamber creates superior mixture motion. Flow bench testing confirms the ports, when properly prepared, exceed wedge head flow. Emissions testing demonstrates cleaner combustion. Everything Petty claimed in 1968 has been validated by science. The broader implications extend beyond just engines. Petty's story is about recognizing hidden value, about questioning conventional wisdom, about the democracy of innovation. He proved that breakthrough performance doesn't require breakthrough budgets. Sometimes it just requires breakthrough thinking. In an era where we're quick to discard the old for the new, where planned obsolescence is business strategy, Petty's Poly reminds us that abandoned technology might just be abandoned treasure. The Chrysler engineers who decided to abandon the Poly made a rational decision based on the information they had. Manufacturing costs mattered. The wedge head was simpler, cheaper, easier to produce in volume. They couldn't have predicted that a 16-year-old kid would prove their abandoned design had untapped potential that exceeded their new technology. But that's exactly what makes this story so powerful. Think about what else we've abandoned, what other technologies were discarded, not because they didn't work, but because they didn't fit the business model. How many innovations are sitting in junkyards, patent offices, or corporate archives, waiting for someone like Petty to recognize their potential? In our rush toward the future, what have we left behind that might actually be better than where we're going? The Poly 318 story isn't just about engines. It's about the nature of progress itself. Real innovation isn't always about inventing something new. Sometimes it's about understanding something old. Petty didn't create new technology. He revealed the technology that was already there, hidden beneath conservative engineering and corporate compromise. He showed us that with enough understanding, enough skill, and enough determination, you can make yesterday's garbage into tomorrow's gold. That primer-spotted dart-running 12s with a $55 engine became more than just a drag strip legend. It became proof that in America, in motorsports, in engineering, the best idea wins. Not the most expensive idea, not the newest idea, the best idea. And sometimes, just sometimes, that idea comes from a 16-year-old kid with $30 in his pocket and a junkyard engine that everyone else threw away. What obsolete technology are you overlooking? What abandoned idea could be your breakthrough? What $55 solution is sitting right in front of you, waiting to embarrass million-dollar problems? That's the real legacy of Richard Petty Jr. and his impossible Poly 318. Not just that he beat 383s with 318 cubic inches, but that he showed us brilliance doesn't require billions. Sometimes all it takes is seeing value where others see scrap. Drop a comment below if you've ever built something everyone said wouldn't work. Share your own David versus Goliath story, because that's what hot rodding, real hot rodding, is all about. Making do, making better, making believers out of doubters. And if you enjoyed this deep dive into one of Mopar's most unlikely success stories, hit that subscribe button. We've got plenty more tales of underdogs, outcasts, and obsolete technology that changed everything.